Hello, Algebra 1A students. This is the video for if you were absent on Friday the 13th. We are basically going to go over what we did in class, and you can download the materials from the website. Now, on the website, there is a graphic organizer called a Frayer model, and it looks something like this when it's filled in. Okay, so you should download that and then copy some of these notes from this video. Feel free to pause and do that now. Okay, so what we're looking at today is a function and how that's different from a relation. So in the middle of your Frayer model, in the circle here, please write function and f parenthesis x. Now what this says is f of x. This is how we denote functions, and what that really saying is with the function f and the input is x. Okay, we're going to use that more next week, so don't worry about it too much right now. Now in your top left-hand corner is a box that's supposed to be for definitions in your own words. As you can see, I have three definitions in our own words. One is a well-behaved relation. The second is it works like a machine, so a function machine. If you put something in, it should do something and give something different out. Now, it should do the same thing with every single thing that you put into your function. Okay? It relates each input to exactly one output. So we don't want to put in, let's say, 0 to our function machine and get out 2 sometimes and 3 another time. We want to always put in 2 and get out 4. Okay? So the right box is for facts or characteristics. And here's where you should note that it can be a rule, a table, a graph, or a map, and that functions are always consistent. So that means for one number, they don't do something different than another. Okay. Lastly, down here in the bottom, I have lots of examples. We want to tell you why these are functions. So a function means that when I put something out, I should put something into my function machine. I should know what I'm going to get out. So here, if I put in A, I know I'm going to get out 2. Here, if I put in B, I know I'm going to get out 2. Here, I put in C, I know I'm not going to get out 3. So that kind of shows me what's going to come out, whatever I put in. Notice it's okay for them to come out as the same thing. It's just that A, when I put it in, doesn't come out as 2 or 3. Okay? Same with this table down here. When I put in 1, I get out 0. When I put in 2, I get out 0. So it doesn't matter that I'm getting out 0 the whole time, because the function is actually multiplying everything by 0. So it's being consistent, it's well behaved. It doesn't matter if it comes out as the same thing. These other examples are pretty straightforward, right? If I put in 2, I get out 3. If I put in 0, I get out -1. If I put in 3, I get out 4. Okay. Lastly, these are just two different ways to represent functions. One is using my input x and my output y. The other is using function notation. Now, we'll talk more on Tuesday about why this is a function. Here are a couple of things that are not a function. For example, this one is not a function because 1 can come out as 4 or 1 can come out as 3. We don't want that. That's not well behaved. Okay. Same idea here. For 2, it can come out as 5 or 2 can come out as 10. And here's yet another example. C can go to 2 or 3. We don't want that. We want C to either go to 2 or 3. Okay, and we'll talk more about why these examples are not functions on Tuesday. Okay, the other thing you want to do is there is a printout of about 10 functions that you want to sort into function and relation. So I just basically made myself a table. On the left that said function, relation was not a function. On the other side, and I sorted them. And once I did, I glued them on this piece of paper. And here's basically your key. So everything on the left here is a function, and everything on the right here is a relation. And I'm going to explain a couple of these. This one is a function. Now, even though they're all going to 5, we know exactly what's coming out when we put in -1. We know exactly what's coming out when we put in 2. Unlike this function, which is a relation, because when I put in 1, I get out either 2, 3, 4, or 8. I don't really know what I'm going to get out. Okay? This one here is a function because with every dot, I only have one dot on each vertical line. So this x only has one output, this x only has one output, x equals 1 only has one output. But over here, on this one down here, you can see that x equals 3 has an output of -1 and of -3. That's not consistent, therefore it is not a function. Okay? So once you've done that, put these in your notes so that you can refer back to them later and bring any questions that you have with you on Monday. We're going to talk about these kind of things again and talk about these kind of graphs.